Hello, I'm Max Tansky, and today I'll be showing you how to find the volume of a surface of revolution by using the washer method and the shell method. Okay, so the first thing you want to do is just read the question. Let omega be the region bounded by the curves x squared equals 4y and x equals 2y. Use the washer method to find an integral or sum of integrals equal to the volume of the solid obtained by rotating omega around the y-axis. You do not need to evaluate the integrals. Alright, so first what you want to do, just take your equations and graph them out. So, that's what I'll do. Hopefully you're not great on drawing because I can't draw very well, but I'll do my best. Around the y-axis, so we got 2, 1, 1, 2, and then x equals 2y is just a line. So 1/2, 1, right there, right here. So just a line going out like that. It's y equals x over 2. I just converted that really quick because I like it. Y equals. It's easier for me. All right, now we want your x squared equals 4y. So 1/4, y would equal 1, right about there. And then right here, 2 should equal 1. So it's going to look something like that. It's very rough, not very good. But the region we want, omega, is right in here. Alright, so for this problem, they want us to use the washer method, which the washer method, the formula for it is right here. Volume equals pi over some interval, and then you take whole radius in terms of y squared minus inner radius in terms of y squared dy. So that's just the washer method formula, and then we're going to have to apply that here. So we draw a little slice in there just to give us an idea of what we're working with, and then we have to identify what the whole radius is and the inner radius. So first, the inner radius is from here to here. It's r of y. And then the outer radius would be from here to here. So I'm going to draw just like this. Okay. So the inner radius goes from 0 to this line right here. So in terms of, it has to be in terms of x. So I'm just going to erase this and write in terms of x because that's what we need. In terms of x, it would be x equals 2y. Okay. So in terms of x, we got the first part of our equation. And then we also need from here to here. So from here to here, it is just this function, x squared equals 4y, or x equals 2 square root of y. So x equals 2 root y. Now we just plug these into our formula. We get pi. I'll show you the limits of integration in a second. From 2 root y squared minus 2y squared dy. And the region is going to set the limits of integration. So it goes from 0, and you want this in terms of y, 0 to 1, because we're operating in dy right here, so the limits of integration are in y, not in x. So then you just carry that out. It's going to equal pi 0 to 1 4y minus 4y squared dy. Factor out that 4. And there you go. That would be the integral for part A. It says we don't need to solve it, so I'm not going to do more work than I have to, just because, you know, the video is short. Keep it short and sweet. Alright, and this one says use the shell method to find an integral or sum of integrals equal to the volume of the solid obtained by rotating omega around the y-axis. You don't have to evaluate the integral. Okay, so the difference, here's the formula first. Formula is 2 pi, your limits of integration, p h. And P stands just for some x or y value. H is the height of the function, then over change of x. Okay. So what you have to do for the shell method is you have to make sure it's parallel to whatever you're rotating around. So since we're rotating it around the y-axis, we're going to need a vertical slice. And we find that vertical slice. With the vertical slice, it'll keep it in terms of x. So we got the vertical slice. Now this will be your p, just some x value of wherever we're in it, like because you have to take it across to find the volume. Just p equals just some x value. And then your h is going to be just the height of this. Just the height of that little piece right there. Which just so happens to be x over 2 minus x squared over 4. And I found that by solving these for y. So you take your equations, solve them for y, you get y equals x over 2 for this one, and you get y equals x squared over 4. Okay, so you just solve for y, and then you just take what you know, you want it to be this height, so it would be this function minus this function, and then the remainder, your difference, will be the height that we're looking for. So that is h. So it's this function minus this function in terms of y will get you this. So then we just take what we know, plug it into the integral, equals 2 pi over the limits x times x over 2 minus x squared over 4 dx. And then our limits of integration, since we're in terms of x here, are going to have to be from 0 to 2, because that's what the region has stated for us. So 0 to 2. Alright, then you just multiply it through and integrate. 2 pi, 0 to 2, x squared over 2 minus x cubed over 4 dx. Cancel out the 2's. Do some simplification here. I'm just going to do it really fast. It's going to equal pi over 2, 0 to 2, 2x squared minus x cubed dx. Alright, so there you go. That would be the integral for solving this using the shell method. Hopefully it was helpful.